Our topic is maxima and minima. The point where the curve is higher than some other adjacent points of the curve is called maximum points, and the function is said to have a maximum value. And the point where the curve is lower than some other adjacent points of the curve is called minimum point, and the function is said to have a minimum value. In other words, if we have a different points in a curve in a Cartesian plane, the most higher point of that value in a curve, we call it maximum point. And the lowest point of the curve along the Cartesian plane is a minimum point. We have a test for maxima and minima. There is a test that we call second derivative test. The second derivative test is the rate of change of the first derivative. When y double prime or the second derivative is positive, y prime is increasing. The curve will concave upward, and when y double prime is negative, y prime is decreasing. The curve will concave downward. So we have two curves that we remember, that is concave downward and concave upward. If y prime is equal to 0 and y double prime is less than 0, the point is maximum point and it concave downward. If y prime is equal to 0 and y double prime is greater than 0, the point is minimum point and it concave upward. If y prime equal to 0 and y double prime equal to 0, the test failed. When the test failed, we going back to first derivative test that we encountered for finding the slope of the curve. In first derivative test, it is stated that at points where y prime is equal to 0 and if y prime changes sign as x increases from 1 negative to positive, we have a changes of sign from negative sign to positive sign. And number 2, from positive sign to negative sign. From negative to positive sign, here y is a minimum, and for positive to negative sign, we have y is a maximum value. And if y prime does not change sign, y is neither maximum nor a minimum. So if we look at in the graph, in a Cartesian plane, we'll put in a graph. will look something like this. This point, that is y prime equals to 0, and this higher part, y prime is greater than 0, and also here in the lower part, that is y is less than 0. This part, x is a constant and not increasing, y prime equals 0, but y prime does not change the sign, so x is a constant yield neither maximum nor a minimum at that point. As a applied example, locate the critical point and determine the maxima and minima of the curve y equals to x cubed plus 3x squared minus 2. We have the solution from the original equation of the curve. First, we get the first derivative. Y prime equals to 3x squared by power formula plus 3 times 2 times x, and the derivative of the constant is 0, so eliminate it. So we have y prime equals to 3x squared plus 6x. Then we set y prime equals to 0 to find the value of x. We set to 0, then we have 3x squared plus x as 6x. So we simplify that term. We have a 3x plus open parentheses x plus 2, and we have two values of x equals 0 and x equals to negative 2. So we have the critical values are x equals 0 and x equals to negative 2. When x equals 0 and plug in to original equation of the curve, which is y equals to x cubed plus 3x squared minus 2, we get a value of y equals to negative 2. And also, when x equals to negative 2, same process, we get the value of y equals to 2. So we have two sets of value, x equals to 0 and y equals to negative 2. Also, x equals to negative 2 and y equals to 2. So now that is the critical point. Then determine the maxima and minima of the curve. For maxima and minima, for the first derivative, y prime equals to 3x squared plus 6x, we get the second derivative, 6x plus 6. And at point 0 and negative 2, we plug into second derivative, the value of x. So we have y double prime equals to 6. It indicates that y double prime is greater than 0, y is minimum. Also at point negative 2 and 2, we plug in to the second derivative, we get the value of negative 6. It indicates that y double prime is less than 0, y is a maximum. So we plot the curve to find whether it's real maximum and minimum. So we have negative 2 and 2. We call it as this phase 1 and 2, that is negative 2 and 2. We have plot here the value that is negative 2 and 2 here. So also the other set is 0 and negative 2. We put in here. So we have here and 0 and negative 2. And if we graph this curve, the original curve, we form like this curve. This is y equals to the function of x, which is the equation of the curve. So we have the minimum here and a maximum here. It is minimum at second derivative of y is equals to 6, and first derivative of y for this set, we got the maximum value. Let's say graph of that curve. Another example, also locate the critical point and determine the maxima and minima of the curve y equals to x cubed plus 5x squared minus 3x minus 4. Same procedure, we have the original equation of the curve. Then first, we get the first derivative. And the first derivative is 3x squared plus 10x plus 3. Then we set to 0 the y prime. So we have 0 equals 3x squared plus 10x plus 3. By simplifying this term, and we have by factoring, we got two values of x also. X equals to negative 1 over 3 and x equals to negative 3. So we have a critical point for x. X equals to negative 1/3 and x equals to negative 3. So we also find the values for y. We expected that if we have a two values of x, we also got two values of y. When x equals to negative 1/3 and it plug into the original equation of the curve, we got the value of y equals to negative 121 over 27. And also, when x equals to negative 3, y equals to 5. So we have two sets of point, x equals to negative 1/3 and y equals to negative 21 over 27. And when x equals to negative 3, we have y equals to 5. So we find the maxima and minima. From first derivative, now we find the second derivative. Y double prime equals to 6x plus 10, and use the critical points at point negative 1 over 3 and negative 121 over 27. Plug into second derivative, so we have 6 times negative 1 over 3 plus 10, so we have y double prime equals to 8. It indicates that y double prime is greater than 0, y is minimum. And at point negative 3 and 5, y double prime equals to 6 times negative 3 plus 10, so we have a negative 8. So because we have negative 8 in here, plus 10, so we have negative 8. It indicates that y double prime is less than 0. Y is a maximum value. Also, we plot it in a curve to Cartesian plane. So first, we use the negative 3, 1, 2, and 3. For example, 3 here, and 5. 1, 2, 3, 4, 5. So the point is here. This is negative 3 and 5. And also negative 1/3. For example, it is here, negative 121 over 27, sometimes more than 4, 1, 2, 1, 2, 3, and 4, something here. That is a negative 1/3, and negative 121 over 27 at this point here, something like here. And also we plot it in a curve. We get this point here, something like that. And also this curve is a function y. Y is a function of x, which is the original equation. Y equals to x cubed plus 5x squared plus 3x minus 4. So this is our example for maxima and minima. And thank you very much. I hope you learn for this topic.